All right. Good evening, everyone. How is everybody? Can someone confirm that you can see my screen and you can hear me? Thank you, Matthew. Are there any questions before we start? Thank you, Ali. All right. So last class, we actually did midterm. After midterm, I gave you a pre-recorded lecture about simple linear regression. So today we'll talk about multiple regression. It is just the extension of simple regression. When you have simple regression, you have one X, one Y. When you have multiple regression, you have many X, maybe X1, X2, X3, etc., but just one Y. And we call Y dependent variable. X1, X2, X3 independent variables. Okay. So that is the difference between simple regression and multiple regression. In multiple regression, we have multiple independent variables. Okay. Just a reminder about a project. It is due week 11. So today is week 7. Sometimes I use the term week and session interchangeably, okay? You can get the time series data or any data you want. The purpose of the project is that you can apply the techniques we learned, okay? So any questions so far? The project due Tuesday or Saturday of the week 11? That is a good question. Anyone, I have to double check the course outline. Okay. Anyone have idea? Did you? I don't have that specific date in mind. I will double check the course outline. So the project week 11, April the 5th. Okay, week 11, April the 5th. So it is Tuesday. Okay, project due Tuesday. Okay. Final exam, the date is in class week 13, April 19. Okay, from 6:30 to 8:30. The format of the final exam will be similar to test 1. Okay. Chapter 6 is required reading. No, chapter 6 is not on the course outline, as you can see here. So we are in week 7. Today we'll talk about multiple regression. Chapter 6 is just a supplement. Okay, but chapter 6 has close connection with chapter 7. Okay. Will test 2 be accumulative? Test 2 will be focused on whatever after test 1. Maybe 80 to 90% will be after test 1. Okay. Other questions? Thank you for your questions. You can ask questions throughout the lecture, okay? All right, so go back. To agenda for today. So we are going to talk about multiple regressions, okay? So I will start off with the example. In this example, you have one dependent variable, y, and you have two independent variables. One is x1 price, the other is x2 advertising. You want to see if there's a linear relationship between y and x1, x2. Okay, so the question asks you, one, create correlation matrix. Two, build a fitted regression function. Okay, so there are two questions here, actually. So now I'm going to open the Excel data file. So cells, not this one. This one here, yes. So you have cells. And you have x1 represent price, x2 advertising, okay? So I'm going to delete this one, restart the process. So question one, create correlation matrix. What is the correlation matrix? It is short correlation coefficient among variables. Okay, so you go to data, and then, data, oops. So I need to move this. Data and then data analysis. Okay, select correlation. Click OK button. So after that, input range. Input range, you can select all the data from A1 to C11. Okay. And it is grouped by column. Okay. Output range, I want to maybe in F4, that's fine. So click OK button. Okay. So this is the correlation coefficient matrix. And how do you interpret this table? So it shows that, of course, one variable related to one variable. It is always one. So y related to y, x1 related to x1, x2 related to x2. Okay. So you want to show what, how related x1 to y, the relationship, the correlation coefficient negative 0.863. Okay, that means when you increase x1 by 1 unit, y decrease by 0.863. The negative means when you increase x, y decrease. Or when you decrease x, y increase. Okay, and the relationship between, for example, x2 and y is that when you increase x2 by 1 unit, y increase by 0.89 unit. Okay, so that is the linear correlation coefficient using Excel. Okay, of course you can use the SPSS. I will going to demonstrate in a few moments. Okay, so we answered one question and we get idea from this matrix. when you increase price, sales will decrease. But when you increase advertising, sales will increase. Question 2, build a fitted regression function. There's a typo here, so not regression function. So how do you build regression function? You can go to data analysis, and then select regression. And click OK button. And now input Y range. So this is my Y. As you can see, I included the labels. So I check out the label. Input X, I have 2X. Okay, so I need to select both of them, B1 to C11. Okay, so that is XY output range. I want to put output maybe here. That's it. Click OK button. So this output is very important. You are expected to explain each and every number. So test to final exam for sure will have questions based on this table. Okay. So pay attention to each and every number here. So the first number is multiple R. It is a linear correlation coefficient. Okay. 0.96. Okay. When you increase combined X and Y, this is combined X1 and X2. Okay. Looks like there's a strong relationship between combined X and Y. So R squared 0.93, the same as 93%. So 93% changes in Y are due to combination of X1 and X2. R squared has a name. So R is linear correlation coefficient. R squared is coefficient of determination. Okay, and adjusted R squared always a little bit smaller than R squared. It is adjusted for sample size and other factors. Okay. And the next number is the standard error. Okay, this standard error is like the standard connect to the standard deviation for regular data. You can consider that standard error. And how this 1.5 is obtained, it is actually, if you take square root of this number, I will go to this number later. So I will explain the number between 1.5 and the number between MSR, mean square due to error. Okay, there are connections between those two numbers. So observations are sample size. We have 10 observations. Okay, so this is a regression statistic. And over here, we have ANOVA table. I will start off with the most important number, significant F. Significant F has another name, p-value. Okay, it is just the p-value. And this value is 8.22 times 10 raised to power -5. This is a very small number, okay? This number for sure will smaller than alpha. Usually, alpha is 0.
Professor?
Yes?
Sorry to interrupt, but where can I find this data set? Is it in Hank? Because I can't seem to find it.
Oh, thank you. It should be in the D2L. I'll check now. If not, I can upload the file right away. Okay, thank you for asking. Please ask questions, anything, okay? So I'm going to go to D2L. So if you go to content, then go to data. I'm not sure if I put it here. I can upload now, okay? So I'm going to upload files. My computer. Yeah, here, chapter 7. Okay, so it should be in chapter 7 file, okay? Chapter 7, there's a tab. There are several files in table 7-4, that is that file. Or another way, this data is from textbook. You can also get, I also give you the textbook data file, right? So this data from textbook, table 7-4. So please download the data file from textbook. See, you can also find it from here, Hanky data. This is our textbook data. Okay, thank you for this question. Any other questions?
Thank you, Professor. That's everything.
Okay, great. All right, so go to minimum this one. So I'm here. All right, so this is the most important number, p-value. This p-value smaller than alpha, that means the model is appropriate. The model is significant. We can use the model to do prediction. So based on p-value method, okay? And then we have this F-test statistic, okay? Remember I said every number in this table is important. So how do you get this number? F-test statistic. You use mean square, MS represent mean square due to regression divided by mean square due to error. So what is mean square due to regression? It is 108. See this keyword, MS mean square due to regression. So it is 108 over MSE. See, this is MSE. E is error. Error is the residue. So it's 2.27. Okay, so you need to understand what is the relationship among these three numbers here. Okay, so now let's analyze how did you get 108? Okay. So this 108, I will just keep 2 decimals. This is MSE, mean square due to regression. MSR, mean square due to regression. This number equal to SSR over degree of freedom for regression for SS, okay? So this is SS stand for sum of squares. R is here, SSR, so the number is 217.7 over degree of freedom is 2. So use 217 divided by 2, you get 108. Okay, so that is MSR. So the next number is MSE, mean square due to error. That number is 15.9. How do you get that? That number is 2.27. How do you get this number? You use 15.90 divided by 7. What is 15.90? That is the sum of square due to error and divided by degree of freedom. That degree of freedom is 7. The formula is n minus k minus 1. N represents sample size is 10. K represents number of independent variables. We have x1, x2, 2 variables. So if you use 10 minus 2 minus 1, you get 7. Okay. This one here, the formula should said SSR divided by K. K represents number of independent variables. Okay, so I explained SS sum of squares. Okay, and if you add those 2 numbers together, you get SST, sum of square for total. Okay, so very important ANOVA table. Okay, any questions? Okay, last table is the coefficient table. What is our question here? Our question asks you to build a fitted regression function, to write down a function. Okay. So the function is based on these 3 numbers. Okay. In high school, you have a B0 intercept, slope for x1, b1, slope for x2, b2. Okay, so use those 3 numbers, you can write down y equal to b0 plus b1x plus b2x. Okay, and what is y? Y is cells, b0 is 16, b1 is negative 8.25, x1 represent price, plus b2, 0.585, x2 represent advertising. So this is your regression equation. Okay, this is your regression equation. I will just try to copy the whole stuff here. I'm going to copy the screen and paste it here as the note. Not here. This is from my another class. What I try to do, I want to copy the screen. So copy screen. Paste. Yeah, so the notes is here. All right. So any questions about example 7.1? Looks like I Where is my again? I need to move this. Did I delete something? Okay, I will fix it later. So that is the example 7.1. Any questions?
Professor,
Yes.
I have a question. I remember in midterm, there's a question about the difference between the mean absolute deviation and the mean square error. So in what situation we're gonna use the MAD, or in which situation we're gonna use the MSE, and why?
Okay, great. So MSD mean standard deviation, absolute MSD, the difference
MAD.
between MSD and MSE, right?
MAD. Mean
MAD.
absolute, yeah.
So the difference between
Mean absolute deviation.
and what? Between this one and which one?
MSE, the mean square error.
Okay. Good question. What is the difference? The difference is the formula. We use different measurement. So mean absolute deviation, we use the forecast error minus predicted error, take absolute value. And then we add them all divided by sample size. Okay, that is the formula for MAD, mean absolute deviation. And MSE, the formula, it is in the textbook I gave you towards the end. I have the formula for this chapter. So MSE formula, yeah, here. Key formulas. You see, this is MSE formula here. MSE. This part, do not look at the square root, is MSE. So you use y minus y hat, square it, add them all divided by n minus k minus 1. So that answered your question. The difference is we use different formula. And then why we use different formula? Because we need to answer different questions. In answering questions about forecasting accuracy, in chapter 3, normally we'll ask for MAD, okay? In regression, we usually ask MSE. Generally speaking, MSE is more popular than MAD, okay? Hope that answered your question.
Thank you. Does it mean that like MSE is more accurate when we use to forecast? Because I do understand the smaller MAD is, the better forecasting technique is.
Yeah, the smaller MSE, the better the forecasting. Same apply to the smaller MAD, the better forecasting. In terms of which one is more accurate, you have to look at the context. You cannot draw general conclusion. Okay, so most often we use MSE.
Okay, thank you.
Use MSE. So the formula for MSE, use y minus y hat, square it, add them all, divided by n minus k minus 1. That is MSE formula. Okay. All right, any other questions? All right, so that is the example. Do you want me to show example in SPSS or you are okay? Anyone? We have just 13 students. Where are other students? The class is shrinking. Excel is fine. Okay, thank you.
Yeah, I think it's okay if you just move on from here.
Okay, thank you. Move on, okay? All right. So next, I will present the next example. Why I lost my slide here? Let me see. I will find it later. So next, I will explain example 2.2. It is based on the same data for example 7.1. Okay, so the question is, if the price is 1 and advertising is 10, ask you to forecast the sales. Okay, so we need to get the output. We need output here. Okay, so remember in example 7.1, we get y equal to 16.406 negative 8.247 x1 0.585 x2. So the question, if price is 1, so you use 1, plug in, and advertising x2 is 10. What is the sales? You plug in, you will get the number. Okay, so it is 16.406 minus 8.247 plus 5.85. So the final answer is 14.06. You get the forecast. Okay, when x1 equal to 1, x2 equal to 10. Okay, so this is this question. And the next question, forecast sales if price increase to 1.01 and advertising is still 10. Okay, so for this question, x1 is 1.01, advertising is 10. Okay, and you can get the result. Okay, as you can see, when you increase the price from $1 to $1.01, sales decrease from 14 to 13. Okay, decreased a little bit from 14.06 decreased to 13.96. So sales, when you increase price, sales decrease. Okay. So next question, forecast sales is advertising increased to 11, but the price is 1. Okay, so price is 1. Price is 1, advertising is 11 times 11. Okay, and you'll get a number 14.65. As you can see, when you increase advertising, sales will increase from 14.06 to 14.65, holding price constant. Okay, so this is a example 7.2. Next, I will introduce standard error of the estimate. Standard error of the estimate here. The one I used, the red one, this one here, 1.5, that is the standard error of the estimate. And this number, 1.5, standard error of estimate 1.5 equal to, use MS E. So this number I use yellow background 2.27. You should take square root of 2.27. Let me double check. Maybe here. Oops. I have a you take square root of 2.27, you get 1.5 standard error. Okay. So you can check out the formula in formula 7.4 refer to the standard error of the estimate. We use this simple S Y X. It is equal to square root of MSE. And what is MSE? MSE is SSE over n minus k minus 1 take square root. That is formula 7.4. Okay. All right. Any questions? The next example is example 7.3. The question asks you, use the data in example 7.1, calculate the standard error of the estimate. Calculate standard error of the estimate. So how do you calculate? Use this table, use this equation. So it is equal to SSE. From here, you get SSE. SSE is 15.901 over n is sample size. K is number of independent variables. We have 2. Okay, and the result, you will get 1.5. Standard error of the estimate. Okay. So any questions? All right. Inference for multiple regression models. We already actually explained the ANOVA table for multiple regression. I explained in detail here. ANOVA table, okay, for multiple regressions. And I also explained F-test for significance. So this is very important formula. What is F statistic equal to MSE over MSR over MSE? Sorry, there is a typo here. Mean square for regression over MSE, mean square for error. MSR over MSE. In our example, what is MSR? It is 108. What is MSE? It is 2.27. So our test statistic 47.92. Okay. So that is a F-test statistic. So next example is example 7.4. Ask you use the same data. Use the same data means this data here, cells x1, x2, to calculate R square. Okay. Of course, you can get R square from here. See, R square 0.93. But when the question asks you to do calculation, you need to use the formula. Okay. So the formula for R square equal to SSR divided by SST. What is SSR from this part? So SSR is 217. Okay. SSR 217.698 divided by SST. SST 233. Okay, you get R squared 0.9319. Okay, and the last part is test significance of individual predictors. use both critical value method and the p-value method. Okay, so the question, remember we have two X, X1 is price, X2 advertising. We are going to ask question, is X1 significant? Is X2 significant? How do we answer that question? Two methods, critical value method and the p-value method. Okay, so when you use critical method, this is an example 7.4. So when you use critical value method, you go this table here. So what is the critical value? Critical value test statistic for X1 is here, negative 3.75, negative 3.75. And the test statistic for X2 is 4.377. Those are test statistics. Obviously, those test statistics are in the rejection region. So you reject H0. Okay, so that is the critical value method. And for p-value, the p-value for X1, 0.007, smaller than alpha. The p-value for X2, 0.003, smaller than alpha. So you reject H0. Both X1 and X2 are significant. So this is a test significance of individual predictors. Okay. Any questions? Next example is about dummy variables. Dummy variables. Again, you can get this data from D2L. Remember, this data is textbook data. Download this zip file so that you have that data. This is the zip file. Okay. Alternatively, I will see if I have that. Alternatively, you can go to chapter 7. I just uploaded. You have this data. Okay. So let's see the question, what we are going to do with this question. So for this question, I'm going to, you could use Excel to do it, but I already show you Excel method. So this example, I will show you SPSS. Okay, so the question asks you to create scatter plot in SPSS. Okay, so now I'm going to open my SPSS. By the way, this data is about Y is rating. You have test, maybe this is the job performance rating, Y. Okay, you have aptitude test score, and then you have gender. We use 0 represent female, 1 represent male. It's pretty slow loading SPSS. Oops, why did I click close? Oh, it's here. All right, so I'm going to open data. You can actually copy and paste from the Excel. I'm going to show you how to copy and paste. So this is the Excel file. When you copy the data into SPSS, do not include label, just the data, okay? Right click your mouse, select copy. And then click this one, paste. After that, you go to variable view, and then you type in the name rating, test, gender. Gender is just 1 and 0. Okay, value. Value is 0, represent female, and if it is 1, represent male. Sorry, this example is not inclusive because we have LGBTQ, okay, other people. Sorry about that. So we have a rating, maybe no decimals. We have test, do we have decimal? No. This rating is about job performance. This test is an aptitude test, okay? Something like your test 1 or final exam mark. So now I go to data view. So this is my data, okay? To create a scatter plot, you go to graph, legacy dialog, and then scatter plot, okay? For this one, we are going to use maybe simple scatter plot, define y, rating is my y, and test is my x, set marker by gender. Okay. And then you click OK button. You have this scatter plot. Okay, so rating is y, test set by female and male. Okay, so this is how you do it using SPSS. Okay. All right, so we are about of the time to take a break. Any questions? Any questions? Okay, guys, take a break. Make sure you take care of yourself, both physically and mentally. Come back at 7:30. We'll continue with example 7.6. Okay, so back at 7:30. I'm going to stop recording. When we come back, I will press recording button again. Where's the recording? Stop recording.